Okay, so we have a total of 6 people in the wedding party, and what we're doing is lining them up for a photograph. So we're going to make a single row. So it's like, 1, 2, 3, 4, 5, 6. 6 rows, 6 blanks. First question. In how many different ways can they line up? Or how many different arrangements are there? Well, there's 6 people. So, you're going to have 6 options for who goes in the first blank, and then you've got 5 options for who goes in the second position. And then you've got 4, and then you've got 3, and then you've got 2, and then the last person will be, there's only going to be one person left at the end, so you put them in the last place. So this is 6 factorial, and that equals 720. So that's the answer to the part A. So now we're going to start putting some more restrictions on this. In how many different ways can they line up so that the bride is next to the groom? Okay, if the bride is going to be next to the groom, let's represent that by writing BG, like that. Bride is next to the groom, like that. You can think of them as one unit. Like, think of the bride and the groom as being glued together, and they are one person. And now instead of 6 people, you have 5 people, right? Because there's them, and then there's, 2 attendants and 2 attendants. It's not necessarily going to be 2 on one side and 2 on the other side. You could have the bride and the groom on the left, and then all the attendants on the right. Whatever, there's different arrangements that we could do here. But now, basically, instead of taking a permutation, counting permutations of 6 things, now we're basically counting permutations of 5 things. One extra caveat is that this BG could have been GB, and you still have the groom and the bride standing next to each other, right? So BG or GB. That's 2 options. So 2 options for how you arrange that. So we can break this down into a sequence of tasks where task 1 is to decide between BG or GB. That's 2 different options there. And then task 2 is arrange the permutation. How many different ways can that be done? Well, since we're doing 5 things now, that's going to be 5 factorial. And these are 2 tasks that you could do in either order. You could arrange them and then decide if it's going to be BG or GB at the end, or you could decide on GB or BG. You could decide on the the order of the bride and groom first, and then arrange the five people, or the super person of the bride and groom together. So those tasks can be done in either order, but you have to do both of them in order to arrive at a a lineup for the photograph, right? So we're going to multiply them together. That's the multiplication rule taking effect. 2 times 5 factorial ends up giving us an answer of, gotta consult my notes, 240 different possible arrangements of that one. So there's that. Now the next question is, in how many different ways can the party line up so that the bride is not next to the groom? Ooh, interesting. So now that we're saying not next to the groom, we can approach this problem not by drawing out different arrangements, but rather by thinking in terms of complements, set complements. So we're talking about a negation here, right? So it's like you've got 720 different ways to line up the entire party, and 240 of those involve the bride and groom standing next to each other. So if you want the bride and the groom to be standing not next to each other, well then it should be the other 720 minus 240, which is 480 ways, right? It's just all the ones that weren't included in the 240. Those other ones are where they're not standing next to each other. So that's the complement of the set. You've got all of the different ways. You've got the set where bride and groom are next to each other. And then out here you have the set where the bride and the groom are not next to each other and there's stuff between them, right? But together, all of those combine up to form all of the different possible, the whole universal set of different arrangements, different permutations of the 6 people. So there's the idea. We're kind of relying on complement. Very similar to that example I did before about, subtracting the strings that involve no x to get all the strings that involve at least one x. Same idea. So now, the last one. In how many different ways can the party line up so that the bride is somewhere to the left of the groom? So we're talking about, like, bride is somewhere to the left, right? And it doesn't matter. You could have some people standing in between them, but the bride's got to be to the left of the groom. This one is tricky. you can start mapping it out like, okay, we could have the bride and groom together on the side, or you could have the bride here and then a blank and then a groom and then 3 blanks, and then you could do 2 blanks between them, and you could keep on going like this, and then you could put a blank at the beginning and put the bride and then you know, and then the groom and then 3 blanks and then blank and bride and then blank and then groom and then 2 blanks and dot dot dot. Like, wow, you could approach it this way. And you know, if you've got some time and you want to try doing that and like systematically going through all the different possible arrangements that have the bride and the groom, bride to the left of the groom, you could do that. And what you're going to do is take the number of these things, the number of those, and take that times 4 factorial. Because once you've placed down the bride and the groom in certain positions, all you have to do is decide what order the other 4 people are going to be standing in. So you've got to take those other 4 people and be like, okay, this is going to be like, you know, Anne and Bob and Chen and Desi, you know, or whoever, like, you know, and then do different arrangements. Or it could be Bob, Chen, Anne, and then Desi, or whatever arrangement those people happen to be standing in. So that's how you would do it that way. But that sounds like a lot of work. I don't really want to go through all that work. Let's see if there's an easier way to do it. Think about this.